Hi, this is group 4 for the Systems and Project Engineering class in fall of 2021. So today we're just going to take you through the system demonstration, and we have a few example scenarios that we feel best demonstrate the functionality of our system. So to get started, I'm just going to run the main file. And as you can see, all the UI windows popped up. So we're going to start off with the track model. And as you can see here, you can load in the track. And then from there, you can select which line you want to use. So today we'll be using the green line. And then you can select a specific block along that line from 1 to 150, because that's how many blocks are in the green line. So we can just try block 79. And then you can see that all of the track properties are displayed here, including the branching, if there's a railway crossing, as well as the committed speed in miles per hour and the committed authority. You can also see the outside status and all the stations within the green line. You can also see down here that there are ticket sales, so how many people are waiting at each station. Up here, just to point out that there you can see the block occupancy, so where the train is on the block. Another functionality of the track model is that it allows you to enter in the desired environmental temperature. So today we can make it 40. We can make it 70, and then degrees Fahrenheit. We can enter that. And then just to show that the track heaters would work, if it's below freezing, we can enter that, and you can see the track heater change from off to on. Additionally, you can select a switch at the top of the block. So for example, we can try block switch 77, and the switch position is currently left. Over here, you can have the Murphy inputs. So this includes breaking a rail, cutting power, destroying a track circuit, and it also gives the Murphy a chance to fix all of those vital failures. And in the bottom, you can see the summary of the circuit status based on those failures, and any current failures will be listed down here. Similarly, you can see all the occupied blocks from the train down in this window here. And now we're going to go to the CTC office. So this UI allows you to dispatch a train. So up here you can select which train you want to dispatch. So we'll dispatch train 1, how fast you want the simulation to go. So for now, we'll go regular speed. And then what station you want. So we can go to Castle Shannon, and you can have the arrival time, 7:15. Then you can dispatch a train, currently at block 63, and there are 33 more blocks before the destination. But you can see that the train is not moving, and this is because we are in manual mode for the train controller. So to change that, you can go to the train controller input. And so the train controller regulates the train speed and velocity. So for this first run through, we are using the hardware train controller. So this is just the software UI of that hardware train controller, which takes in any inputs from the driver. And then additionally, for the hardware UI down here, we have the status of the left doors, the right doors, the headlights, the interior lights, and the intercom. So anytime that these are enabled, those updates can be seen down there. and it allows the engineer to enter the KP and KI values. So for now, we will do 200,000 and 0.2. And then we can give the set point speed as 25. And you can see the power was initially set, and the speed is rapidly increasing because it's accelerating. And then if we go back to the CTC office, we should be able to see the train occupancy change. And you can see that the train moved from block 63 to 64. So just to take another look at the train controller and the train model. So the train model shows the next destination, the status of the doors, the emergency brakes for the passengers, as well as Murphy inputs to brake the engine, brake the signal, and brake the brake, and the status of all of those. Similarly, you can see that the status of the train information up here matches what is shown on the train controller. And you can even see the status of the train controller on the right-hand side. Just to show how they interact, we can add the service brakes to the train controller, and you can see the train speed is decreasing dramatically, which matches the train here, and you can see that the brake signal has gone to true. And then if we take off the service brakes here, you can see that both windows are increasing at the same rate. And then now if you do the emergency brakes, similarly, the speed goes down, and you can see the emergency brakes are activated on the train model. Similarly, if we take off the emergency brakes and the Murphy brakes the engine, it acts as if the emergency brakes have gone on and the train comes to a stop. And then the Murphy can repair the engine and it continues on as normal. And then similarly, if you break the brake signal, the signal again treats it as if the service brakes were on, and then you can repair the signal. And then if you break the brake, it uses friction to come to a stop. So we can see that here, as you can see, because it's only using the friction, it takes slightly longer to brake. And then you can repair that brake, and the train will continue as normal. So coming back here, for now, we can speed up the simulation up to 10 times the speed, and you can see that it's going quite a bit faster. You can go back to the UI. And now that it is at Castle Shannon, it has stopped. And then we can go to the train controller UI, as well as the train model UI. And you can see that the driver can open the left doors, and then you can see the door status here. And then you can close the left doors, open the right doors, close the right doors, turn on the headlights, the interior lights, and the intercom. And all of these values can be updated in the train model. So we can close all of these values. And that is the train model and controller. Now I'm going to run the simulation again so we can focus on the other modules as well. Go back to the code base. So I'll first go to the track model, import the track, and select a line. And then what I really wanted to focus on a little bit more this time was the waysides and the CTC. So talking a little bit about the waysides, first I'll start with the hardware track controller. For the green line has 7 waysides total. 1 of them is in hardware and 6 of them are in software. So the hardware track controller controls blocks 1 through 22 of the green line. And in this diagram above, you can see that there is a switch at block 13 and a traffic light at block 1. So down here, you have a place where the programmer can enter a new PLC. So when this module is initially started, there is a PLC that gets automatically loaded in. However, if the programmer wanted to change the Boolean logic associated with the PLC, they could do so here. And then talking a little bit about the hardware UI, up here you have the wayside block close signal. So if the CTC closes a block, that should go high. I have the track status, which is determined by the PLC. That talks about the switch state, the crossing bars, the crossing lights, and the traffic lights. And then down here you have vital failures. So that includes a broken rail, a circuit failure, and power failure. So if the Murphy triggers any of those failures, the changes should be seen here. Just to show how the PLC can be changed, I have set up an example PLC that would toggle all those values for the track status. So I will enter that here. And as you can see, all this PLC track status values have been toggled. Similarly, from the CTC office, you can close a block for shutdown. So I will select block 13 because I have a switch on block 13, and then I will enable the shutdown. So as you can see, the wayside block close signal has come on high. And then down here, there's a switch. So right now it's on left, so I can switch it to be on right. And as you can see, that value has been toggled. Now you can disable the shutdown. And as you can see, the wayside block close signal has gone low and that block is now opened again. All right, so now talking about the, so this time we have a software train controller, also dispatched to Castle Shannon. So this is the train controller UI for the software. You can see that the driver can input the service brakes, the emergency brakes, the set point speed, as well as view the failures here. The engineer can enter the KP, KI. The peripherals could be toggled up here, and the inside temperature can be set. And then the beacon would display the next station in this box here. So for now, we'll put the KP as 200,000, the KI is 0.2, and the set point speed is 25. As you can see, the power started and the speed is increasing. You can see the next station here is Glenberry. And the speed is slowing down because it's capped at 25. So if the driver wanted to increase that or decrease that, they could do so by just changing this value. As you can see, it went from 25 and it's continuing to increase. And then similarly comparing this with the train model. So the train model has, the Murphy has the ability to brake the engine. You can see that this signal has gone high and the train is rapidly decelerating. Similarly, you could repair that and starting to speed up again. Then you could break the signal. And again, it decreases. And you can repair the signal. And then it's accelerating. And then you can break the brakes and it will use friction to slow down to a stop. You can repair the brakes here. Now I will go back to the CTC office and go on 10 times speed to speed this up a little bit. As you can see, it's going quite a bit faster. So now that it's at the station, we can bring back the two windows and the train driver can open the right doors. And you can see that over here, the right doors are open, can close the right doors, open the left doors, close the left doors, turn on the headlights, the interior lights, they can turn off, and then turn on the intercom, and all of those changes appear here in the train controller. Similarly, they can change the inside temperature. So they could change it to 72. And that is reflected here as well. So we're going to run the simulation once more to wrap up the functionality of the system. And go back to the base. And as you can see, the windows pop up once more. So we're going to import the track, select the green line again. And then this time I wanted to talk a little bit more about the software track controller. So as I mentioned before, there were 7 waysides in the green line. The first one is hardware and the next 6 are software. So through the UI, you can select which wayside you want to view. So I'll do wayside 4. And then within there, you can see what line this wayside resides on, what blocks are controlled by the wayside, and where the switches are located within this wayside. You also have the option to select a block from that wayside, and doing so will give you a little bit more insight into what's on that block. So for example, you can see whether it's occupied or unoccupied, if the switch state is left, right, if there is a traffic light on the block or crossing gate on the block, and if so, it would say the status of those. And then at the bottom, you have the failures. So if the Murphy were to trigger a failure, that can be shown down here. So similar to the other one, it loads in an initial PLC, but just to show the functionality of that switching, we have another PLC ready to alter those values. So you do PLC2.text file. And then if you go back to block 77, you can see that that changed from left to right. And then similarly, you look at the CTC office. you can toggle a shutdown. So I will go to block 77. And then I will enable that shutdown. So if you go back to the Wayside UI, you can see that the status about block 77 is now closed. So the switch state is currently right. So if we can change that to left, so let me just move this window out of the way. But if we select left, then we can go back to the Wayside and you can see that the switch state is currently left. Now we can just dispatch a train again. And this run through will just focus on the vital failures, vital responses of the Waysides. So I will dispatch to Castle Shannon once more, and then go to the driver UI, give it the KP 200,000, and then KI2, and then the set point of 25. So you can see the power and the speed turned on, and we'll run it 10 times the speed until it gets into Wayside 4, and then I can demonstrate a little bit more of the functionality. All right, so I will pause the simulation here. It's currently on block 76. So just to talk a little bit more about the functionality of the Wayside itself. You can see that block 76 is occupied. And there are no broken rails, no broken circuits, and sort of goes hand in hand with the track model. So if you select block 77 here, 76, sorry, you can see that the occupancy is true. And then if you go to the next block, you can see that the switch position is left. And then similarly, if you go to block 77 on this UI, you can see that the switch state is also left. So now we want to break a block that's coming up soon. So we could break block 83, and we can break that rail. So you can see this little pop-up window comes up saying that there's a failure detected by Wayside 4. You can click OK, and then you can see this failure is currently there. So we can go back to the track model and we can go block 83. You can see that there is the broken rail updated here as well. So we can go and fix the rail. And you can see it is fixed here as well. So now we can disable the shutdown for block 77. And you can see that the train is continuing along the path after being shut down. And now I want to show similar vital failures happening in the hardware interface. So I'm going to bring the controller back and I will select block 10. And I will break the rail block 10. And as you can see, the broken rail signal has come on high. And then I will fix the rail. And as you can see, that vital failure is no longer enabled. So that's the functionality of our system. Thank you so much for taking the time to watch it. Any functionality that we were unable to get as a system, We were able to get individually, and that can be seen through our test UIs, which will follow this. Thank you.
This is my simulation for the CTC office. So as you can see on the inputs, you have the destination, dispatch, the switch, which way you want the switch to go, the current time, the arrival time. And then on the right, on the outputs, you have all the occupancies of the blocks. You have the switch status, either right or left. This time for switch 5 to 6, 5 to 6, or 5 to 11. You have the destination, the block, the route, the arrival time, and the suggested speed as well. So say you want to dispatch a train to get to station A at 7:30 from 7:15. So if you dispatch it, you can see that the route is now going from 1 to 10 with a suggested speed of 55 miles per hour, or kilometers per hour. I mean, the real arrival time is 7:30 as well. And if you move the train, you can see that the location updates and is now going through the route. Keep moving it, keep moving it, keep moving it. And right here, if you switch the switch to 5 to 11, then you press move train, you can see that it won't go because of the switch status is not going in the correct direction. So then if you put it back to 5 to 6 and move it, it will go back to the route it's supposed to take. And as you can see, it updates every single time it moves the occupancy of the blocks and the location of the train. It displays the occupancy of the blocks is a better way to say it, I guess. And then if you want to reset it, it goes back to that. Station B, dispatch, you can see at block 1, it's at block 1, move train, and it goes through the route. And as you can see, it got blocked at block 5 because the switch status was the wrong way. If you switch that, then it goes through the correct route.
All right, hi everybody, my name is Ashley. I worked on the software track controller for group 4. And today I'm going to go over some of the software waysides functionality in greater detail. So today I'm going to be testing the green line with blocks 1 through 20. Now in our system integration, the hardware track controller actually controls this section of the block, but I wanted to show that both software and hardware could do the same functions. So I marked up the green line a little bit just so it'd be clear where everything is located. So the switch is on block 13. If the switch to the right, we are going from blocks 13 to 1, so D to A. If the switch to the left, we're going from blocks 13 to 12, so D to C. There's also railway crossings on block 19. So opening up my UI, you'll be able to enter in the speed limit. Now the speed limit in the system integration is received by the track controller. So right now I'm just going to enter in 40, and this will be the speed limit for all of the 20 blocks. Now I'm going to enter in the suggested speed. The suggested speed in the system integration is received by the CTC office. So right now I'm going to enter in a speed limit that is below the speed limits from before, so 30. I'm going to enter in a suggested authority, which is also received by the CTC. So for the purpose of this demonstration, let's say I want to go from blocks E to A. So E, D, C, all the way up to A. I'm going to enter in the authority for that, which is over here. And then I'm going to enter in occupancy, which would be received by the track model. So I'm going to say that there are no other trains on the track at the moment. So occupancy would be all 0. And then I go ahead and press update. Now in the lower corner, you can see the commanded speed was calculated. The commanded speed is going to be the same as the suggested speed in this case, because the suggested speeds were under the speed limit, so they were accepted as the commanded speed. If I were to change the suggested speed for all blocks to, let's say, 50, and press update, the commanded speed gets calculated to be 40 kilometers per hour since the suggested speed was above the limit and therefore unsafe for the track. Commanded authority is also calculated and sent to the track model. Since there are no other trains at the moment, it is the same as the suggested authority. The calculation is implemented using redundancy and is based on how the PLC reacts to the given occupancy. And then last but not least, occupancy. This is the occupancy from the track model. It's going to be sent to the CTC office. So the PLC, the wayside automatically loads in this file called plc.txt, which tells the wayside what Boolean logic to use. So here in this statement, this is the logic used to determine the position of the switch. So the wayside's going to look at the commanded authority for block 12 and the inverted commanded authority for block 1. The PLC also determines the location of the switch. So the switch is located on 13. It determines the location of the traffic lights. Traffic light 1 is on block 1. Traffic light 2 is on block 12. And then last but not least, it also determines the location of the railway crossings. So RC equals 19. Railway crossings are on block 19. So going back to the UI, if I select block 13, which is the location of the switch, you'll see that it's in the left position, indicating that we're going from blocks 12 to 13. So for reference, we're going from D, section D, to C. If I were to change the occupancy to be, if I were to change the occupancy on block 12, and I update that, I update block 13, the switch is now pointing to the right. As this is part of the safety critical architecture, even though the suggested speed wants to move the train to blocks 12 and 13, because there is a train already on block 12, the switch will be set to right. So it's also possible to change how the PLC reacts using a new PLC file. So I went ahead and made another PLC file called plc2.txt, which inverts the logic used in the previous PLC file. So the switch is going to be determining position based on the inverted commanded authority for block 12 and the inverted commanded authority for block 1. So if I go ahead, let's reset this occupancy value, update that, and get the switch to go back to left as we had it in the beginning. I update the plc2.txt file, upload that, refresh, and now the switch is automatically default to the right. So like I mentioned previously, the PLC also determines the location of the railway crossing bars. So the right here, I'm going to once again reload the old plc.txt file. And so I'm going to go to blocks 19. Right now, the railway crossing bars are disabled. If I were to change the occupancy on block 19 to be 1, so let's say that there is a train there, update that, I refresh 19, the railway crossing bars are now enabled. Same thing for traffic lights. Those were located here in the PLC. So if I go to both of those blocks, 12, right now they're green because both of those blocks are unoccupied. If I change one of the blocks to be occupied, so let's say I change block 12 again, update that, go to block 12, and the traffic lights are now red. Okay, so in maintenance mode, the CTC is able to toggle the position of the switch. So I'm going to demonstrate that here. If I go back to the switch block and I press toggle, I update the switch and the switch will now be on the left. I toggle it again, the switch will now be pointing right. Same thing with the railway crossing bars, I can toggle that. I go to block 19, They're enabled. I toggle again. They're disabled. So also in maintenance mode, the CTC is able to open and close a block. So I'm going to select a block down here, let's say block 4, and I'm going to close that. And if you can see, the commanded authority for position 4 and commanded speed for position 4 got set to 0. That's so that no other trains can enter that block. If I go up to block 4, the rail status will show that it's closed. I can then reopen this block. The commanded authority and commanded speed get recalculated. I go back and refresh the block. It's now good. Right, so in the event of a failure, the track model will send a signal to the wayside. So I'm just going to run through all of the failures really quickly. So I'm going to select block 7. I'll break that rail. As you can see, in commanded authority and commanded speed, position 7 got set to 0 so that no other trains can access that block. I go to that block, the rail status is critical. I can fix the rail. Commanded authority and commanded speed get recalculated. I refresh block 7, rail status is good. Similarly with the circuit, break the circuit, commanded authority and commanded speed get set to 0. I refresh block 7, circuit status becomes critical. I fix the circuit, recalculated authority and speed. Block 7, the circuit status becomes good. And then last but not least, cutting the power, again, with the authority and the speed, they get set to 0. Power status shows up critical. I fix the power, recalculated commanded authority and commanded speed, and then the status will show up as good. And in the system integration, you wouldn't have to keep manually clicking on the blocks to refresh it. The signals are running at a constant timer, so you wouldn't have to reselect the block. I didn't use a timer in this demonstration just so I could go at my own pace, but in the system integration, you'll see that the wayside updates in real time. Okay, that is about everything. Thank you for your time.
Hi, this is Maya, and I'm going to go through the functionality of the hardware track controller module for the Systems in Project Engineering class in fall 2021. First, I'm going to go through my test UI and some sample scenarios, and then briefly talk about the PLC language that was used and the safety critical architecture that was implemented. So I'll first start by talking about my hardware interface. As you can see here at the top, I have a wayside block close signal. So what this does is anytime the CTC closes the block for maintenance, this light should turn on until all blocks the wayside controls are open. And then here you have the track status. This includes the switch states, the crossing bars, the crossing lights, and the traffic lights. And all of these status signals are determined by the PLC. And then over here you have vital failures, which includes broken rail, a circuit failure, and a power failure. And anytime Murphy triggers these failures, these lights should indicate which one was triggered. All right, so now talking about the test UI. The wayside controller is in charge of blocks 1 through 22 in the green line. And this picture above also specifies where the switch and the traffic light is. Our system is designed to pass occupancy, speed limit, suggested speeds, and suggested authorities in the form of binary strings or arrays. But for the purposes of demonstrating the functionality of this module, I'll be using this left-hand side, which will automatically create the binary strings in the back end, depending on where we want to place the train, which will save us some time in this demonstration. So then down at the bottom, we have several toggle values, which are in place to show how the CTC or the Murphy can toggle a switch or a railway crossing in maintenance mode. And there's also this location here where we can upload a PLC if needed. So when this module is started, a PLC is initially loaded into the module, but to demonstrate how the PLC is read and how it works, I have another file that can be uploaded to change the direction of the switch, raise the crossing bars and turn on the lights, and also change the traffic lights to green. So I will enter that in the text box here, upload it, and as you can see, all these values were toggled. So now you can see there is a traffic light located here by block 1, and this traffic light is to show the safety of a train coming from this loop into this bidirectional track area. So right now the PLC is designed to turn the traffic light to red if any of the blocks in this bidirectional track from blocks 13 to 22 are occupied. So to show that, I will put a train at location 17. When I update it, you can see that the traffic light here changed from green to red. All right, so this module also gets signals from the Murphy, and what the Murphy can do is he can toggle the broken rail failure mode, the circuit failure mode, and the power failure modes. So an example of that, I will just use these toggle buttons. And now you can see all of the vital failures are on. And then I will toggle all of them off. And now you can see they're no longer enabled. All right, so over here by block 19, there is a railway crossing, and the PLC signifies that if there is a block, one before and one after, as well as on 19, so 18, 19, and 20, the railway should be enabled. And to show that, let me move this train to 19, update this, and as you can see, the crossing bars and lights both changed due to the presence of that train. So now focusing on the switch direction changes based on the route as long as it follows the safety outlined in the PLC. So to demonstrate this, I will put a train on block 3, so at the Pioneer station, and I will have the route from Pioneer to station 16. Select that and then update it. And as you can see, the switch state changed from left to right because the right connects block 1 to block 13, which would allow the train to travel from Pioneer to station 16. However, if there was a train on block 13, you can see that the switch state here changed back to left. And so what this does is it forces the first train to wait at block 1 until the train at block 13 can travel to block 12. And so it's out of the way of the first train to avoid any collisions. So that is how our safety architecture is implemented. All right, so the CTC also has the ability to close a block to put it in maintenance mode. So right here, I have a little drop down that will let me select any block. So I'll pick block 5, then I'll click close block. And as you can see here, the wayside block close signal is high. So then if I wanted to open the block, I click this open block button. And as you can see, the block turned off, signifying that all blocks in the wayside are now opened. Just really quickly show a little bit about the PLC. I have an example here. So as you can see, all the language used in this PLC is completely Boolean based. And that's the functionality of the hardware track controller. Thank you so much for taking the time to listen.
Hello, my name's Eileen, and I'm the track model. And today I will be demonstrating the functionality of my track model using my test UI. So first, I'm going to show that I can load a track model. As you can see, I currently do not have any choices to select for track, block, and switch. But once I select this import track button, then it reads CSV files from a folder and populates the select track dropdown. So there are two files, one for green line, one for red line. You see there's nothing in the block and switch dropdowns yet. I can select one of them, select green line. Now I have all the information for the green line here. And now the station information is down here, and you can see the ticket sales are loading in. They're increasing over time. I could press clock speed multiplier, multiply by 0 to pause it, and this acts similarly to how the system clock will work, where you could pause, have it run in real time, clock time, and run at 10 times speed. And so back to loading the track, I could also select red line, and it will load all the blocks and stations and everything for the red line. And go back to green line. So now I'm going to show that I could display all the track properties to the user. So select, say, green line block 1. So here I'm going to go down this list. I'm displaying section, block ID, previous block ID, next block ID. This is just a general to give a general idea of the path you could take in the block. If it's bidirectional, previous block ID and next ID may be switched. Block occupancy is false. Switch position is not applicable, which is what it says when there's no switch. If there is a switch, it will say left or right. Direction of travel can be unidirectional or bidirectional. Commanded authority, commanded speed, these are in the track signal. To show that the track signal is going through from the track circuit to the train, and the authority and commanded speed are given by the track controller. I have speed limit, grade, elevation, cumulative elevation, length, and then I have station. If there's a station here, I'll say the station name. Railway crossing lights and railway crossing bar. So there's two blocks there's one block on each line that has a railway crossing. So here we go to 19. Now you can see the lights are off, the bar's up. And then I could show you, I could toggle state of each of these. So I could turn lights on, bar down. I could do the same in the red line. So red line block 47. These lights are off and up as opposed to the ones on the green line. I could toggle them on the red line too. I'll remember it because it's stored in the track model. And I'll turn them both off for now. Up next, I have environmental temperature. So by default, it's at 60 degrees Fahrenheit, about 16 degrees Celsius. And so I could input whatever I want, 20 degrees Celsius and 40 degrees Fahrenheit. And then here I have the status of the track heater. It turns on automatically when the temperature falls below freezing, which is 32 degrees Fahrenheit and 0 degrees Celsius. So I'll test it here. See here, the track heater turns on. Anything under that, still on. It's 33, it's off. And it's on here. Alright, and finally in this list, list, I have beacon, and it just displays the signal of the beacon if there's a beacon on the block. So the way that beacons are set up on the track, so there's a beacon on around every station. So say central, go to central, and you see the beacon displays the current track or the current station, the name of the current station on the station, and then you can see the station is here. And for a bidirectional station on a bidirectional block, the signal is also on the block before and on the block after. This is on a unidirectional track, so it is not on the block after. Yeah. And now I'm gonna show that I could toggle my switches. So I'm gonna switch 13. See the switch position is currently left. Set this position right. Now it says it's right, and the next block ID has also changed. Finally, I'm gonna set the commanded speed and the commanded authority. I could do that on this block. Commanded speed, I could say 60 miles per hour. It shows up here. Commanded authority, I'll send it to true. This one is the same and true. Okay, so now blocks 13 through 15 on the green line have commanded authority true, commanded speed 60 miles per hour, and this will be stored in the track model, and when a train goes over the block, this will be sent to the train. Yeah, and now I have Murphy inputs, so I could break a rail to cause block failure, power, cause power failure, circuit failure. I could fix each of these, and when one of the statuses, when Murphy breaks something, the status of that block becomes poor, and the failure becomes displayed for the entire track. I could go around destroying multiple blocks in multiple ways. I can go on the red line too, destroy some blocks, and then I can go around and fix them. So let's see, fix power, go back to 15, fix rail, and the red line, fix, what was that? Oh, block failure. Okay, and then in the system, when these failures occur, they get sent to, well, their effects cause failure mode to go off, and the system reacts accordingly. So now I will show the train going around the track. So I'll go around the green line first. I'll dispatch a train from the yard, and now train 1 is on block 63 right here. You can see the numbers on this map are the ranges of blocks in each section shown. So the train's gonna go down this way first and hit this switch. The switches to the all switches are set to the left by default, so I'll have to go to this switch. It's on switch 77 and set it right, and then advance the train. And I also want to show that I could stop at stations, so I'm gonna go to, I guess I already passed Dormont. I'm gonna go to Mount Lebanon on block 77 and stop at that station. Now train has stopped at station Mount Lebanon. 74 people onboarded and 47 offboarded. So the number of people onboarded was randomly generated by the track model station, and the number of people offboarded is also random. So my train that I'm using for the purposes of this demonstration has been already loaded with people initially, So there are people offboarding on the first station. In a more realistic scenario, there would not be people offboarding a train on the first station because there not be people yet. Yeah, so I'm gonna advance the train some more. It's on this stretch now. It's gonna enter this loop. That has to deal with switch 85. And so it's left by default, so that's fine. I'll just go around the loop now. He's in the loop. It's about to exit the loop now, so I have to switch to switch right. And then advance the train. Now it's back here, going the other direction. So I had added some logic for the train to be aware of which direction it's going, so it's able to go on bi-directional tracks. So now I have to set the switch left. Now the train is going on this path. Yeah. And now we have to deal with this switch. So switch 29. So you switch right. Now the train can go up here. It's going to go around this loop. That's switch 13. It's left by default, that's good. Go into the loop. Oh, almost exited the loop. Gotta switch this right. Now we're back to switch 29. We gotta switch it left because we want the train to go back to there. Alright, so now I'm gonna demonstrate that the train can also go through the red line. So now I'm gonna dispatch a new train from yard. Train 2 is gonna be on block 9. So we're gonna start out advancing the train here. It's going off the top of this loop. I'm gonna have to go to switch, 16. It's left by default, so you can just keep going. Now I have to go past all these 4 switches, and so I want to go down the straight path first. So let's see, switch 27 should be left, 33 needs to be right, 38 left, 44 right. So now there's a straight path down, like the train can just go. The train's around here now. It's about to enter this loop. So this switch is left by default, so I'm just gonna leave it there. Now it's in the loop. Ooh, okay. And now I'm gonna set the switch right. And the train is going back out the loop. Yeah, I almost passed it. So now I wanna go, instead of going straight through, I wanna go on these paths to show that I can. So I'm gonna set this switch to the left, and basically switch every switch to the opposite of what it was. So I can go on the other path. There's a train. Now it's on 67, and it's 71. Back to 38, this straight one here. And now it jumps to 72 right here. And 76, and now it's back on here. And now this is gonna go back through. Going back here. And one last thing I wanted to demonstrate was that I could have multiple trains. Well, I just demonstrated I could have trains going on red and green line at the same time. I also want to demonstrate that I could have trains on the same line at the same time too. So I'll dispatch one more from the yard. That was train 3 on block 63. And he can go as he pleases. And oh, he derailed because I didn't set the switch. But yeah, train 1 can go back to the yard now. And yeah. Oh, and I just wanted to mention that command speed and authority is 0 and false for pretty much all the blocks. That is because I do not want to set them individually for all the blocks, and it was not my responsibility to base my train's movement based on the command speed and authority. I just did all.
All right, hi, I'm gonna show you my screen so that we can see that my module works. I'm the software train controller for group 4. And let me just set this up real quick. Okay. So here's my module. And first off, we need to input a KP and KI value. And then we should be able to set our set point, 25. And as you can see here, it starts to go. And here's the power output capped at 120,000. So as this is going up, I can just show that these peripherals do indeed work. So we turn on headlights, doors, open and close. Here it shows that it does indeed work. Lights, intercom. Over here. I can show that temperature outputs on this display, which will also be sent to train model, and then outside temp I'm supposed to be receiving from the train model, but I don't think the connections are quite right, so hopefully it will be by the presentation time. Here we got our suggested speed to be 40. So the driver can input 40 if he really wants to, and it goes up. But as you saw, it also didn't exceed 25 as well. And here, if we use brakes, speed starts to go down. And it decreases up until 0. And we'll release it, and then it goes back to the last speed that it was given by the set point. And if we use emergency brake, it goes down much faster, as you can see, and stops at 0. Release it, and then we go back again. And here our next station is shady side, and then it'll change as soon as we get to the station. And then we have our failure modes. So if I pull up train model real quick here. So we say we brake the engine, we brake, and then it comes to 0. And here it shows that it's critical as well, so that the driver knows. And then we repair it, and we're all good again, and then we go back up. Here we break the signal, and I don't receive any signals, and then we just brake. And then we go back, we repair it. And then we break the brakes, and then we just come to a coast since the brakes aren't working, and then it goes to 0, power output 0. We repair it, and then we're going back again. So, and that's it. That was my UI demonstration. So thank you.
Okay, so this is my video on the train controller hardware version. So right now this is my UI for the train controller along with these LEDs right here. And then I also have up the train model UI as well. So right now the situation is that there's a train dispatched on the track, but it's just sitting there and not moving yet. So first off, we can set our KP and KI engineer inputs. So now those are set. And we can choose a driver set point, let's say 10 miles an hour, and enter that. And you'll see power shoot up and cap off at 120,000 watts. And speed will shoot up to 10 miles an hour, and we'll see that regulate to that. So let's see that first. So that will regulate to 10. And then I can decrease the speed to 5 miles an hour. And we should see that the train will slow down to 5 miles an hour. And then one more time, I can increase the speed up to 10 again. Okay, and then as the driver, I can pull the emergency brakes, and we'll see speed go down to 0 and stay there. Then I can release the emergency brakes, and speed will go back up to that 10 mile an hour set point. Similarly, I can do that with these service brakes, and speed will decrease just at a slower rate, and it will stay at 0. So while the train's not moving, I'll show you the utilities. So on these LEDs, you can see I can open the left doors, the right doors, turn on the headlights, the interior lights, and the intercom. And then as well, I can turn all of them off or close them. I can close the right doors and the left doors. Okay, now I will release the service brakes. So speed will go back up to 10 miles an hour. And I will show you the failure modes. So I can brake the engine, and when I do that, the emergency brakes will be pulled, and you'll see that the engine is now in the critical state, and speed goes back down to 0. As well, I can repair it. The engine is now operational, and speed will go back up. I can do the same thing with the signal. I can break the signal, it is critical now, and the emergency brakes will be pulled, and speed will be 0. And then I can repair it, it's now operational, and speed will go back up. And then for braking the brakes, due to friction, the train should just coast to a stop. So we'll see that. So the brakes are no longer working, and the train is slowly coming to a stop. And then I can repair the brakes, and speed will go back up to 10 miles an hour. So thanks for watching, and that was my video.